Hello, mathematicians, and welcome to the Unit 5, Lesson 5 review. Today we are going to be talking about the angle-side-angle congruence theorem. Looking in our textbook, or online resource, I should say, angle-side-angle looks at two angles and a single side. Now, in our pictures here, you can see that it's important to note that when we discussed side, angle, side, we talked about how the angle had to be included, like in the middle between the two sides. In this case, angle, side, angle is the same but reverse. So we know two angles, and that side has to be right smack dab in between them to show that two triangles are congruent. So if we walk around our triangle, right, the angle, the side, and the next angle will be back to back to back to back. It can't be angle, side, and then the other angle being over here. We want them to be included in between each other. The other important note, the note that I put on all the lessons prior to this, right? Rigid transformations maintain congruence. We can flip, twist, move, groove our figure around as much as we want to. It just might be a little bit difficult to identify what sides are corresponding to each other, but it maintains congruence. So let's look at some examples. In this case here, right, we've got a couple of transformations. In this figure here, we have a reflection. In this figure here, we have a rotation and then a reflection, right? In this case, our image is always going to be congruent. We just might need to do a little bit of work and explain to people why they're congruent. So if I were to look on this side, if I were using angle, side, angle, right, we know that by the reflexive property, figures are congruent to each other. So, right, when we reflect this across here, the reflective property is going to tell us that angle F is going to be congruent to angle C prime, angle D is going to be reflective to, or congruent to angle A prime. And then most importantly, in how we actually use the congruence or the reflexive property is that A double prime, C double prime is congruent to DF, right? So these figures are congruent to each other. We just have to identify those corresponding sides. Luckily, in this picture here, they have them labeled. So there's no questions that angle F is congruent to angle C prime because we have our angle markers here. Looking at the next image, this is an example from your curriculum where they state that angle A is rotated to where A prime, B prime, C prime is at. And then we have a reflection that occurs here. And once again, we have that reflexive property that tells us, right, that CE is congruent to itself. And then we even have the markers here that tell us our angles are congruent as well. Moving on to another example, we are going to look at these three triangles and try and identify which ones are congruent to each other. So looking at triangle 1, we're working with angle, side, angle. Remember that. So we want to look for an angle, a side, and then another angle. So right now we have angle, side, angle for triangle 1, but we need to confirm that it matches with any of the other triangles. In triangle 2, right, we have side and then an angle and then another angle, right, as we're walking around our triangle. Side, angle, angle, that is not what we're looking for, and that's not even a congruence theorem in this case. So this one is nope, not it. Let's look at our third one here. We have our angle here, which is 26. We've got our angle here, 26. We've got our side of 6 here, and then our angle of 45 here. So actually, if I were to rotate this and translate it down, these triangles would perfectly lie on top of each other, and by angle, side, angle, triangle 1 and triangle 3 would be congruent. Okay, what else is needed? This is going to be a question that you are asked regularly in all of our lessons, right? So in this case here, we have our triangle, which is actually labeled for us for both of our angles. So we have angle D here with a single arc mark for the angle, and then we have angle A here, which also has a single arc mark. So this is actually showing that these two angles are congruent. Now, if I were to take angle or triangle DEF here and rotate it and then translate it, it would match up right here, right? This would be pointing down, this would be pointing up, this would be pointing to the left, just like C is here. And so in this case, we have angles on either side of what would kind of be our hypotenuse if we were working with a right angle, right, our longest side. We have angle B marking up with angle E and angle D marking up with angle A. Now remember, with angle side angle, right, we want our side to be right smack dab in the middle, and the angle or the side that would be needed then is this side here. We want to know, is this side here that's right smack dab in between them, is it congruent, so that we can prove that the triangles are congruent. Now remember that order matters. So when we're doing this, if I wanted to say is AB, or what we need is AB is congruent to the same side over here, you notice that I said A first. A is the single tick mark, B is the double tick mark. So over here, I'm going to start with the single tick mark E, and I'm going to match it up with the double tick mark E. Okay, and so the part or the information that we would need is that line segment AB is congruent to line segment DE. Let's look at some more examples here. This is a solving for X example that I just wanted to go over because we haven't solved for equations in a little while, and yes, equations aren't going away. Okay, and so for this one, we have triangle ABC and DEF, and they give us that angle B and angle E are congruent, angle C and angle F are congruent, line segment BC is congruent to line segment EF, and then they give us some length representations. Now, I don't know about you, I can't really picture what's happening. So the first thing that I do if a picture is not provided is I draw a picture. So I'm going to have two triangles. Bear with me, I promise they're triangles. Pretend like they are perfectly congruent to each other. And we've got A, B, C. And remember, when we're working with order, A, B, C, and D, E, F, right? We can put them on top of each other, and we know A goes with B, B goes with E, and C goes with F. So I have A, B, C, and then over here, I'm going to do D, E, F in that same walking around order. And they tell us that angle B is congruent to angle E, so I'm going to mark it with my angle tick mark. Angle C, double, is congruent to angle F, double. And then they tell us that BC is congruent to EF. So basically what this given information is telling us is that we have an angle side angle congruence theorem here, right? All of our sides match up. When we walk around the triangle, they're one right after another, they're corresponding, right? We've got all of the things that we need to prove that ABC is congruent to DEF. Now, we have, remember that funny theorem CPCTC that says corresponding parts of congruent triangles are congruent. So we know by the given that these are congruent. So that means that all the corresponding parts, right, in that case it's A and D match up, right, A and D match up. We know that they're congruent because they're corresponding. We have DF and AC that are going to be congruent to each other, and we have AB is going to be congruent to DE here. So remember this for our triangle. So now let's look at the second part of our question. So it says that if the length of AB is represented by 2x plus 6, and the length of DE is represented by 4x plus or minus for x minus 10, what is the value of x? So let's figure out where on our triangle these line segments are located. So we have DE here, and we have AB here. So we're talking about corresponding sides. And what did we say about CPCTC? What we said was corresponding sides to, or parts to corresponding triangles are congruent. So we know by CPCTC that AB is congruent to DE. Congruence meaning exact same shape, exact same size. So that means the measure of these two are going to be equal. So to set up our equation, we can take our two expressions, 2x plus 6, and set it equal to 4x minus 10. Now that we have our equation, from here we are going to solve for x. And this is something that you saw in 7th grade, 8th grade, 9th grade, right? Moving all on through. And so what we want to do here is I like to split my equations so that I know that my two sides, what I do to one side of my dotted line, I have to do to the other side of my dotted line. And I want to move my x's and numbers onto each one of the sides. I want all x's on one side, all numbers on the other. I like to look at what side has the most x's, which is this side. So this is going to be my x's side, and this is going to be my numbers side. Okay, so if I have x's over here, which I do, 2x, I'm going to get rid of it by subtracting. But what I do to one side, I have to do to the other. So that gets rid of this. I'm left with nothing but a 6 on this side. Okay, and then 4x minus 2x leaves me 2 x's. 4 minus 2 is 2, and I still have my 10. Now, I don't want numbers on this side, so I'm going to do the opposite, which I'm subtracting here. I'm going to add 10 to this side, which means I want to add 10 to this side, which gives me 16 is equal to 2x. I want just a single x when I'm trying to find the value of x, right? I just want one x. So what I am going to do is take my 2 x's and divide it by 2. What I do to one side, I do to the other. So that means that x, the value of x, is equal to 8. Okay, value of x is equal to 8. There's a little quick review on solving for equations, multi-step equations there, just in case it's something that you haven't seen in a while. All right, let's move on to some practice problems. Now, one thing you have seen a lot in all of these practice problems is a lot of words and a lot of transformations. So let's break this one down. We have a sequence of rigid transformations that maps A, B, C to A double prime, B double prime, C double prime. And they give us some information. They give us that angle C here is congruent to angle C double prime, which is this one here. This triangle right here, I know it might be hard to see, but this is A double prime, A double prime, B double prime, C double prime right here. So that they're saying that angle C is congruent to angle C double prime. They're saying that BC, which is this one right here, is congruent to B double prime, C double prime, which is this one right here, right? So I'm gonna do my little tick marks. Okay. What additional congruent statement would be needed to prove that these triangles are congruent by angle, side, angle? So in this case here, if I were to walk around the triangle, I have a side and then I have an angle. Okay, if I were to say that I have a side and I have an angle, I'm missing an angle, right? So if I were to go all the way across, my next angle would be angle A, and that's way too far away, right? We have a line, or we have a line segment that is going to be in the middle. So what we want in this case is our angle, because we want our side to be in the middle. Okay, we want our angle to be first. So in that case, it is going to have to be angle B, right? Angle B is going to be what sandwiches our side in between two angles. So we want to show that angle B is congruent to angle B double prime to prove angle side angle congruence. Next, problem 2, this is another one that does not have a picture. So this is going to be an example where I'm going to have to, if I'm doing this by paper, reading the lesson, I might have like a little notepad where I'm scratching pictures so I can see what's happening. Okay, and this is saying that triangle ABC is, we have triangle ABC and we have triangle DEF, okay? And it's telling me that angle A is congruent to angle D and B is congruent to E. So let's draw those as pictures. We have A, B, C. The corresponding parts then would be D, E, F. And it's saying that angle A is congruent to angle D and angle B is congruent to angle E. What additional information is needed to prove that triangle ABC is congruent to angle DEF by angle side angle? So in this case, I've got the two angles, I need the side. And remember that we want that side to be included. We want it to be like smack dab in the middle of our two angles. So in that case, the one that's smack dab in the middle of our two angles is this here. And realistically, I should put a question mark, pretend like this is a question mark, right? We want to show that this line segment here, this side, is congruent. And what is that? What sides are those? It is AB, which we want to show is congruent to DE, right? I went AB, DE. We're going to look over here in our options and look for AB and DE. So that means option 3 is the information that we need. Up next, we've got problem 3. And I don't know if you guys noticed it, but I'm looking at this kite. Technically, it's a kite right now, right? This triangle that was reflected over the line segment. And I'm like, reflexive. That's immediately what I'm going to think here. So we have a diagram that shows, look at this type of naming here. Okay, we have angle HGI. They use the full name of this angle. So what this is saying is angle HGI. So the G is going to be the vertex of the angle. So they're talking about this one right here. And then when we are looking at the next one, angle JGI, same thing, JGI means that we're talking about this angle here because the G once again is going to be the vertex. So we're talking about the blue and the green. And it's saying that these angles are congruent. It's also saying that GIH, which is this one here, and GIJ are also congruent. I'm going to erase this because we actually already have our arc marks here proving, or not proving, but showing that these angles are congruent to each other. And so we're getting asked, what additional congruent statement must be made based on the diagrams? Once again, we have two angles that we're working with, okay, for side angle side, and we need to know what our side is. And in this case, we want the side that's smack dab in the middle of the two, which is going to be this one here, which is GI. And so we're going to want to show that GI is congruent to GI. If I was doing this, right, I would say by the reflexive property, right, that GI is congruent to GI, but we're not. We just want to know what that side length is. Last question is using that exact same problem, right, or exact same figure, but we want to know what theorem proves it. I just answered this question, right? If we have an angle and another angle, and we want to know that GI is congruent to each other, which it is by the reflexive property, we would have angle side angle as our theorem. Alrighty guys, that is it for Unit 5, Lesson 5, Angle Side Angle Congruence Theorem. please reach out if you have any questions, and until next time.